Hello everyone, I'm Felix. Today we will take a look at how the computing power platform operates and works. The role of the computing power network is to provide computing power resource services for users. It completely integrates computing power resources into the communication network and provides computing power resource services that best meet user needs in a more holistic form. This is a highly flexible and highly intelligent network. The core feature of the computing power network is that it uses computing power to achieve comprehensive takeover of computing power resources and network resources, allowing the network to perceive the user's computing power needs and its own computing power status in real time. After analysis, the computing power network can dispatch computing power resources of different locations and types to serve users. We can understand it as a universal faucet. It can always provide water flow with appropriate strength, temperature, and pH according to your needs so that you can have the best water experience. Then, we will naturally be very curious. What kind of water network is behind this universal faucet? How does it control and dispatch resources? Next, let's take a look at the architecture of the computing network. Let's draw a simple diagram. In short, it is still the layered idea of information communication. If you look at it by level, you can sort out your ideas. In order to reduce the pressure of reading, you can pass the green and low carbon and security protection on the right first. Let's look at it from bottom to top, layer by layer. The bottom layer of the computing network is still the computing network infrastructure layer, which cannot be escaped. In the computing network, the infrastructure is no longer just computing resources, CPU, storage, GPU, etc., but also includes network resources. On the computing resource side, the integration of computing infrastructure is still based on cloud technology, including cloud-native virtualization, containers, etc. On the network side, the changes are relatively large. To explain the changes in the network under the trend of cloud network integration in one sentence, it is to make the closed network more open decoupled so that it can be like a computer and it can be commanded through software defined. The bottom layer of the network physical layer, data link layer, on the transmission network side is still light. Only light can guarantee basic hard indicators, such as communication, bandwidth, and capacity. The optical underlying technologies, such as ONT, aux, etc., are still the same. There is no difference. On the access network side, 5 grams NR, PON 50 GPON. There is nothing special except that edge computing power will be somewhat related. Going up, there are differences. Because the computing power network needs to dispatch computing power and network resources, it is necessary to pre-process and connect the resources. At this level, the most noteworthy thing is computing power routing. The biggest difference between computing power networks and traditional networks is that they have three major characteristics. The first major characteristic is computing power routing. Before computing power, we must first talk about computing power perception. Computing power perception is the network's comprehensive perception of the deployment location, real-time status, load information, and business needs of computing power resources and computing power services. China Mobile's Computing Power Perception Network white paper is analyzed from the perspective of computing power perception. On the one hand, each computing power node will publish the computing network information measurement modeling uniformly, and the network will aggregate the computing network information reported by multiple nodes to build a global unified computing network status view. On the other hand, the network completes the unified analysis of the business computing network requirements, realizes the comprehensive perception of the business, and provides guarantee for computing power scheduling based on business needs. To put it bluntly, the purpose of computing power perception is to find out how many resources are in hand and what kind of needs the users have. The perceived objects must be measured and identified. So, there are computing power measurement and computing power identification. Operators currently attach great importance to these two areas. There are diversity in computing power, and there are also heterogeneous hardware chips. So there is no unified measurement system and standard. The computing power identification is equivalent to the ID card of computing power. Users indicate the required services through the computing power identification, and the network obtains information such as the target computing power service and computing power requirements by parsing the computing power identification, providing a basis for computing power scheduling. The computing power identification must be globally unified and verifiable. The computing power routing layer in the diagram is the core functional layer of the computing power perception network, which supports the perception and notification of multidimensional resources and services such as network and computing, and realizes the joint scheduling of network plus computing. The computing power routing layer including computing power routing control technology and computing power routing forwarding technology, realizes on-demand scheduling of business requests at the routing layer. Speaking of computing power routing, we must talk about CFN computing first networking. CFN is sometimes used to refer to the entire computing power network in a broad sense. However, here, CFN is a distributed routing protocol that performs on-demand scheduling and balancing of computing power between different edge clouds. CFN is actually very interesting. The routing we traditionally understand is the routing of data packets. The routing here in CFN is to publish the computing resource status and network resource status as routing information to the network. Then the network routes the computing task message to the most suitable computing node based on the virtual service ID. Obviously, computing power routing and CFN are the prerequisites for computing power scheduling in the upper layer. The above is today's sharing content. Thank you for your support and viewing. We will continue tomorrow.